Let's talk about two pieces of technology that are so fundamental to our digital world, you've almost certainly used an app today that was built with them. I'm talking about Git and GitHub, the engine and really the social network that quietly power pretty much all of modern software development.
Oh, we've all been there, right? You're working on a big project and your folder just starts to look like a cry for help. It's complete chaos. How do you possibly track all the changes? How do you go back to an older version if you mess something up? And, maybe most importantly, how on earth do you work with other people without constantly overwriting each other's work? This is the core problem that a brilliant type of tool called a version control system was designed to solve.
So, the first attempts to solve this problem, well, they looked a lot like a library. Just imagine one central server, one single source of truth that held every single version of a project's files. If you wanted to work on something, you literally had to check it out from this central library.
And this slide shows the very first step on that journey. Before we even had a central server, there was local version control. A system like RCS would keep a database right on your own computer. Now, it didn't store a full copy of every single version. Instead, it did something really clever. It stored patch sets, basically just the differences between files, and it could rebuild any version you needed on the fly. Pretty smart.
But, to really collaborate with a team, you need something more. And for many, many years, systems like Subversion and Perforce were the answer. This is the Centralized Version Control System, or CVCS. Everyone on the team connects to that one central server to get the latest files and to submit their changes. And for a long, long time, this was the industry standard.
The benefit was pretty obvious. Everyone knew exactly where the official version of the project lived. But there was a massive drawback. That central server was a single point of failure. If it crashed or the network went down, nobody could collaborate. Nobody. You couldn't save your changes, you couldn't get the latest work, the entire team was just stuck. And this crucial vulnerability, well, it really set the stage for a revolution.
The next chapter in our story isn't some slow evolution. It's a sudden, dramatic crisis that forced the creation of something entirely new. And the protagonist of this story? None other than Linus Torvalds, the creator of the Linux operating system.
So, in the early 2000s, the massive global team of developers building the Linux kernel used this commercial tool called BitKeeper. But in 2005, that relationship completely soured, and their free access was suddenly revoked. Just like that, they lost their most critical tool overnight. So what did Linus Torvalds do? Well, he did what he does best. He basically disappeared for about 10 days and invented his own tool from scratch. He created Git.
And he wasn't just building a replacement. He was building the tool he'd always wanted. His goals were incredibly ambitious. It had to be fast. Ridiculously fast. It needed a simple design, but it also had to support the complex, nonlinear way his team worked, with literally thousands of developers working in parallel. And most importantly, it had to be fully distributed to avoid that single point of failure.
And this idea, this concept of being fully distributed, was the absolute game changer. It wasn't just another feature. It was a completely different philosophy about how collaboration should even work.
So, here's the crucial point. With a distributed version control system, or DVCS, you don't just check out the latest version of the files. No, you clone the entire repository. That means every single developer gets a full, complete mirror of the project, including its entire history, right on their local machine. So, instead of one central library, it's like everyone on the team gets their own personal copy of the whole library.
And this diagram illustrates that idea perfectly. If that central server goes up in flames, it honestly doesn't matter. Any one of the clones on any developer's computer can be used to restore the whole thing. Every single clone is a complete backup of everything. This solved that single point of failure problem in the most elegant way possible. Now, the side effect of this design was breathtaking speed. Because you have the entire history of the project sitting right there on your local disk, most operations are almost instantaneous. Browsing history, comparing versions, creating branches, it all just happens locally, with zero network lag. It really felt, as the creators put it, like the gods of speed had blessed Git with unworldly powers.
So Git was this incredibly powerful engine. But, an engine needs a car. And for millions of developers, that car became GitHub. It took the raw power of Git and built this intuitive web-based platform all around it, turning version control into a collaborative, almost social experience.
Think of it this way. Git is the tool, but GitHub became the place. It's the world's largest host for code, but it's so much more than just storage. It's the hub where the open source community and countless private companies all gather to build software together.
Platforms like GitHub and its competitor GitLab basically create a home base for a project. You get a single web page where you can see all the code, track issues, and follow the project's activity, which makes even these huge, complex projects understandable at a glance.
They also make managing a team incredibly simple. With a clean interface like this one, you can easily add collaborators and manage exactly who has permission to work on the project. It's all right there.
But maybe the most important innovation of all is the pull request. This is the real heart of social coding. When you want to contribute a change, you don't just push your code in. You open a pull request, which is essentially a formal request to merge your changes. And this kicks off a whole conversation. Your team can review the code, suggest improvements, and discuss everything right there, line by line, before anything becomes part of the official project.
So what's the big picture here? Why do these tools matter so much? Well, it's because they fundamentally change the speed and the scale at which we can all collaborate to build really complex things.
From its humble origins as a crisis management tool for a niche community, Git has grown to become the undisputed standard. I mean, whether you're working at a tech giant or contributing to a small open-source project, the odds are overwhelmingly high that you are using Git.
And the scale is just staggering. We're talking millions of developers and millions upon millions of projects that rely on Git and platforms like GitHub every single day. This collaborative framework is the foundation upon which so much of the modern internet and the software we all use is built.
Which really leaves us with a final thought. Git and GitHub didn't just solve a technical problem of managing file versions. They created a new, massively scalable model for human collaboration. They made it possible for a global team of strangers to work together seamlessly on some of the most complex projects in human history. So the real question is, what other big, challenging problems could we solve if we applied this same model of distributed, transparent collaboration?